This is video 5 of the trigonometry video series, and we're looking at angles of elevation and depression in this video. Angles of elevation. Now, an angle of elevation is an angle up from the horizontal. Here's a diagram. Here's a horizontal. And here's what we call a line of sight if we're looking up from the ground to maybe a balloon, blue balloon. Not easy to say. And the angle that is up from the horizontal is called the angle of elevation. So theta there would be called an angle of elevation because that is an angle made up from the horizontal. Now that can allow us to make a right angle triangle in many cases, to use that angle of elevation with our other trigonometry ratios of sine, cos and tan, or even to kick in a lot of different trigonometry rules once we've got that angle in the right place. Now, angles of depression. When you're feeling depressed, you're feeling down. That might help you remember that an angle of depression is an angle down from the horizontal. Let's create a diagram to illustrate that. Here we have some lines, but we're going to pretend there's a cliff, and we're going to pretend that that cliff is vertical. And we're going to pretend that the sea is horizontal. It rarely is, but still. In theory, we could think of the sea as being horizontal. And let's pretend we have a boat. And let's pretend we're standing on the top of the cliff. Now we could have a pretend horizontal line out from the top of the cliff. And we could have an angle describing our line of sight from the top of the cliff down to the boat. And it would be that angle up there with the red arrow there that indicates our angle of depression this time, because that's down from that top horizontal. Okay, now a special thing we can kick in here with angles of depression, and it comes in handy when we combine it with another rule. When using an angle of depression, we very often use the rule that alternate angles are equal in parallel lines. Now, it's a bit hard to spot the parallel lines at the moment. I'm going to make it obvious in a second. But you can see that there's a horizontal across from the top of the cliff, and there's a horizontal that we're pretending the sea is down the bottom. And so I'm going to put big blue arrows here to indicate the two parallel lines. And alternate angles are one of those three rules, alternate, corresponding and co-interior, that we can kick in when we have two parallel lines cut by a third line called a transversal. So you'll remember that from your geometry perhaps. So that allows us to then do a fancy thing by moving that theta that we got from thinking of the angle of depression down into an alternative position down the bottom here. Now there's a reason for that I'll go into in a second, but we can use that rule, alternate angles are equal in parallel lines, to allow us to reposition that theta into a more useful position. So by moving theta to its alternate position down there, and I'm just having a play on words there for my enjoyment, I like to entertain myself at times. By moving theta to its alternate position, this allows us to use the angle as part of a right angle triangle to get our answer. So the angle of depression while it was up the top there wasn't really a part of a right angle triangle, and so we're making it be part of a right angle triangle to help our solving of the answer, solving of the question. Okay, so let's just summarize. The angle of elevation is an angle up from a horizontal. The angle of depression is an angle down from the horizontal. And just to recap, when we're using an angle of depression, we really often use that rule, alternate angles are equal in parallel lines, to reposition that theta into an alternate position to allow us to then use all the rules for right angle triangles, such as sine, cos and tan. So we'll have a look in the next video how we might solve some problems using questions that involve angle of elevation and angle of depression, but it's good to be clear on the definitions before we get on to the problems. So I hope that helps, and I'll see you next time for some more problems. Gee, maths, there's always problems, isn't there? Thankfully we've got some solutions as well. Thanks for watching. See you next time.